Hello viewers, in today's session we are going to discuss another important and conceptual problem from functions. And here we are given this problem where we have two functions f of x and g of x such that f of x is equal to signum of x and g of x is equal to x minus greatest integer of x minus 3 for all values of x belonging to the set of real numbers. And further, here we are given that the composition of the functions f and g, that is f of g of x is equal to 2 minus natural log of lambda, and where lambda belongs to r, then we have to find the value of lambda, right? So let us see how we can find out the value of lambda using the concept of signum function and fractional part function, right? Because here we have x minus greatest integer of x, and the fractional part function of x is defined as the difference of x and greatest integer of x. So now let us start with this function that is g of x. So g of x is equal to x minus greatest integer of x minus 3. Now we know that the fractional part of x is defined as x minus greatest integer of x. And we know that the range of fractional part function is given by this interval, that is 0 comma 1. So here 0 is included and 1 is not included, right? Okay, so now let us replace x minus greatest integer of x by fractional part of x. So here we have now fractional part of x minus 3. Okay, so now here we have fractional part of x belonging to this interval, so we can now write fractional part of x, and here we have 0 and here we have 1. So we can also write this expression like this inequality. Okay, so now let us subtract 3 throughout this inequality, because here we have a fractional part of x minus 3. So let us subtract 3 throughout. So we have 0 minus 3, and here we have fractional part of x minus 3, and we have 1 minus 3. So we have minus 3, and fractional part of x minus 3 can now be replaced by this function g of x. So here we have g of x, and here we have 1 minus 3 minus 2. So now g of x has this range, that is g of x belongs to the interval that is minus 3 comma minus 2 for all x belonging to r, right? Okay, so now let us see this function f of x. Now f of x is given as a signum function. So we define signum function like this, that is signum of x is equal to plus 1 whenever x is greater than 0. Signum of x is 0 when x is 0, and signum of x is minus 1 when x less than 0. So whenever x is a positive number, that is x greater than 0, then signum of x takes the value plus 1, and when x is equal to 0, that is signum of 0 is defined as 0. And when x is a negative number, that is x less than 0, then signum of x takes the value minus 1. So now so far we have obtained this inequality, that is g of x is greater than or equal to minus 3 and less than minus 2. And we have also defined the function f of x, which is the signum function like this. So now let us take the composition of f of g of x. Now see, here we have f of g of x. So now we have to calculate the value of f when the input is g of x, right? So here g of x, it belongs to this interval, that is -3 to -2, and from this inequality we can easily conclude that g of x is always a negative quantity, right? Because for all values of x belonging to R, because g of x has the range from -3 to -2. So all values of x belonging to R, g of x is going to be negative, right? So this is an important step while solving this problem. So g of x is always going to be a negative number, because it lies from -3 to -2, and all the numbers which lies in the in between -3 and -2 are negative. So g of x is always going to be a negative number for all x belonging to R. So we have to now calculate this value, that is f of some negative number, right? And from the definition of f of x, we can see that whenever x is less than 0, that is the input is less than 0 or it is a negative number, then f of x takes the value -1. So in this case we have f of g of x, and g of x is negative due to this inequality. So we have to compute f of a negative number, right? And whenever the input is a negative number or negative value, that is x less than 0, then f of x is -1. So f of negative number is -1. So the value of f of g of x, that is the composition of f and g, is given by -1 for all values of x belonging to R. So now in the given problem, we are given that f of g of x is equal to 2 minus natural log of lambda. So here we have this expression is equal to 2 minus natural log of lambda. So now we have an equation in lambda. So 2 minus natural log of lambda is equal to -1. So we have here minus log of lambda is equal to -1 -2, and this is -3, and cancelling this these negative signs, we have natural log of lambda is equal to 3, right? So we can also write it like this: log of lambda to the base e, and here we have 3. So from the definition of logarithm, we can now write this statement as lambda is equal to e raised to 3, right? So the value of lambda is equal to e raised to 3.